Ground displacement mapping with PALSAR-2 ScanSAR data. This work was performed at Gamma Remote Sensing AG in Switzerland. We conducted INSAR time series analysis using PALSAR-2 ScanSAR data over the Swiss Alps. In this presentation, I tried to give an idea of the methodology used and the results obtained. PALSAR-2 ScanSAR SLC data are available in full aperture mode in COS format. The SLC provided are in separate files per subswath. The bursts are synchronized. The subswath SLCs are on different spatial grids, and the phases of the subswath SLCs are consistent. We considered two alternative processing approaches. The first one was merging subswath interferograms in the map geometry. The second one, merging subswath SLCs in the slant range geometry. The phase terms considered in the analysis are the topographic phase, which is simulated using a digital elevation model, an overall phase ramp, which is relevant especially for early dates. It is estimated based on the data and then subtracted. Then the atmospheric ionospheric path delay, it is estimated based on the data and subtracted. I jump directly to the result of the PSI processing here. We see the result over the 350 kilometer wide swath, here over a large part of the Swiss Alps. The color scale used is between plus and minus 5 cm per year. To see more details, we move in and look at the section including Grindelwald. Here, the green colors indicate stability. Red and blue colors indicate movements away, respectively, towards the radar satellite. We clearly see landslide movements, and the one in blue color is actually a forest covered area. So in spite of vegetation, we get a quite nice result. Besides interpreting directly the result of the overview processing, we do sometimes a local reprocessing, as shown here for Natturns in southern Tyrol. We clearly see with a very good spatial coverage and high point density, two landslides indicated here with the red circles. If we look at the same area, at the result achieved with C-band data from Sentinel as presented by the European Ground Motion Service, we see that there are large gaps in these areas, and it is not at all clear that these are landslides. So in conclusion, we can say that PALSAR ScanSAR data are well suited for differential interferometry and interferometric time series analysis. The L-band data also showed some potential for faster and non-uniform movements and for vegetated areas. Using 14 scenes over 4 years, a displacement map over the Swiss Alps could be generated.